So my name is Sashank Sabbineni. I'm a senior at NC State, majoring in biochem. And so my project is on Alzheimer's disease and glial processes. So basically, Alzheimer's is the 7th leading cause of death in the United States. And so what we wanted to look at was, does alcohol exposure increase or decrease the progression of Alzheimer's disease? And so a little background info. So this is a healthy brain over here, and so it has 2 neurons that are continuously firing, and it's perfect. It's living in an ideal world. But on the right side, you've got a shriveled up, a lot of lost cortical mass, and that's representation of the Alzheimer's brain. And what you've got here is 2 neurons that are being blocked from firing because of these things called NFTs, which are neurofibrillary tangles. And so what they do is they block the firing of neurons, and if neurons can't fire, that's never a good thing. It leads to brain death. That's why Alzheimer's is so deadly. And so what we wanted to see again is alcohol exposure on the progression of Alzheimer's disease. So we took 2 cohorts of mice and we exposed them to water and ethanol, and we wanted to take a closer look at, would the mice pick water or would they pick ethanol? And so what we found out was they continuously picked ethanol, or also known as alcohol, and we noticed that they were picking water or picking alcohol over water continuously for the entire 20 weeks that we ran the study on. And so we saw that in the ethanol exposed mice, on the right side, the brain has an exponential increase in the amount of A beta plaques, and there was a decrease in cortical mass, and the cortical atrophy also increased. So cortical atrophy is like the degradation of tissue on the surface. So like the entire cortical surface here was shriveled up, kind of like that. So basically everything that could possibly go wrong with the brain went wrong whenever we exposed it to alcohol. And so we wanted to take a closer look at the ethanol exposed brains, and so we did X34 staining. X34 staining is really, really important because it allows us to get a molecular view of the A beta plaques. And so what X34 does is it's a molecule that binds to the A beta plaques and it illuminates it. So for example, all these purple dots are a representation of the blue dots that we have up there, and it's just illuminating it much better so that we can get a molecular level view of how these A beta plaques are behaving in the brain. And so what we noticed was that these plaques were being localized to the brain vasculature. So brain vasculature, you can just basically, it's synonymous for blood vessels in the brain. And so we noticed that all these plaques were being localized to the blood vessels, which is never a good thing because blood vessels play such an important and crucial role in the brain, right? So you've got this blood vessel here, and so if we go based off of our conclusion that all these plaques are localizing within the blood vessel, that's really bad because you have all of these different types of glia. Glia are neurons that play a significant, unique role in the brain. So what you've got here is microglia, you've got astrocytes, you've got oligodendrocytes. So microglia are like the garbage men of the brain. They pick up any kind of waste. Astrocytes maintain the blood-brain barrier. Oligodendrocytes create the myelin sheath in the neurons. But the main point of this is that if you've got plaque localization in the blood vessels, that means that these other cells are gonna be affected by that. And so we wanted to take a closer look at how these other cells are being affected, how these other cells are behaving in this scenario. So we ran qPCR, and we wanted to take a closer look at the gene expression of these each unique cells, and we noticed that astrocytes increased in gene expression. So we don't know how or why they behaved, but all we know is that astrocytes there's a correlation between astrocytes increasing and the localization of A beta plaques within the vasculature. So that's basically all it was. Thank you, I appreciate it.